we're going to bring in more parts to our triangle and use that to set up proportions when the triangles are similar. So this is very similar, no pun intended, to the last couple of sections that we've been doing. We're just, anytime you get similar triangles, you know you have angles that are congruent and sides that are proportional. Well, there's some extra meaning with our proportionalism in our similar triangles. So let's take a look at this first one. If two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of corresponding sides. So basically, not only are the sides proportional, but the altitudes are proportional to the sides as well. Well, what's an altitude again? We got to think back to the chapter when we talked about orthocenters, circumcenters, incenter, so on and so forth. An altitude is from vertice to opposite perpendicular. So for example, if I look at B, the opposite perpendicular would be straight down here. So there would be an altitude. We'll just call that X. That's fine, we'll call that point X. Same thing if I drew the altitude from E on this other one, I would go straight down and I would be about right there, and we'll call that guy Y. So for example, if these two triangles are similar, I could set BX over EY because they correspond, they're both the altitudes, and I could set that equal to basically any sides that correspond to the other triangles. Well, I put BX on top, so I got to look at this triangle first. Well, I could set what BC over EF because BC and EF correspond. I could have put AB over DE or AC over DF as well. It doesn't matter. Okay, they all would work. So still just working with our proportional parts, except now altitudes are also proportional. Okay, we had a couple others back in that chapter which are also proportional. Another one is an angle bisector. Okay, so angle bisectors of similar triangles are also proportional to the sides. So for example, angle bisector, if I drew one from A to the opposite side, it's got to split that angle. So something like that. So I knew that it would split the angle into congruent parts there. Same thing. B and A correspond, so if I drew an angle bisector here, I could set up a proportion as well. Let's draw in some letters again, so X and Y. I could say AX over DY because they correspond, those are the angle bisectors, is equal to, well, let's just pick a side. Let's go with AC here. So I'm dealing with that first triangle on top over, well, that corresponds to DF, so DF on bottom. So angle bisectors are also proportional. And the last one are medians. Remember medians, right? I think about middle. So it's from vertice to opposite midpoint. So a midpoint on AC is about right there. Boom. So there would be a median. That would split those two to be congruent. Same thing here. Opposite midpoint. Something like that. So a proportion that I could set up, for example, would be BX over the other median, which is EY. And I could set that equal to, well, let's just say BC matches up with EF over here. Okay, so just setting up proportions. Let's take a look at this here. So in the figure, I have similar triangles. Find the value of X. So what it looks like I have from vertice to opposite midpoint here. So this is a median. So I can set up a proportion. Well, let's just start. Let's just pick the side of X. This guy corresponds to what? This guy in the other triangle. So X over 5 equals, well, let's go back to the first triangle because that's what I have on top. And 12. And I know that corresponds with 8. So there you go. So there's my proportion I can work with. And it's just like we always do with our proportions. Take the cross product. So 8x. 5 times 12 is 60. And divide by 8 on both sides. And x equals 7.5. And that's what, shall we check back? What is it asking for? Value of X. I'm done. There you go. So just setting up proportions. Our last rule, our last theorem, we have triangle angle bisector. Well, if I have an angle bisector in a triangle, so for example here, that means JM is an angle bisector, which makes those two angles congruent. It separates the opposite side into two segments that are proportional to the lengths of the other two sides. Well, that's just saying, so basically split this into this piece and this piece right here, right? So those sides are going to end up being proportional. So if JM is an angle bisector, I could state that, well, Km corresponds to ml. So we'll go Km over ml equals, well, I started with Km, and that's part of this green piece, right? So I got to put JK on top. And then that would be over, well, JK corresponds to JL. So there is a proportion I could set up. So just some more proportional parts to use. And let's take a look at that. It could be straightforward just like this. So for example, I would set 15, well, that corresponds to 9 over 9 equals, well, I got to go back to the side that 15's on. So x has to go on top over 6. And then we just solve our cross product like before. So 15 times 6, which is 90. 9 times x, which is 9x. Set them equal, divide by 9, and x equals 10. And that's all it's asking for. Or it could be a little bit trickier where you got to think some. Well, if I look here, I still have an angle bisector. Right, doing that angle bisector right there. Just remember, figures are never drawn to scale anymore. They just can't fit them to scale in the book. So just remember that. Well, let's take a look. I could set 15 over 27, right? Because these two sides correspond. Because they're right with the angles that work together. Well then, the angle bisector splits this guy up over here. Well, let's think about this. 15, do I know what this distance is? It doesn't say, right? I don't want to put 28 anywhere because that doesn't match up. This needs to go on top because it goes with my 15, right? These two go together, so it's got to go on top. Well, if I look at it, if B is right here, it's just B less than 28, right? It's 28 minus B. That's that blue piece would be 28 minus B. And I would put that over, well, it corresponds with the side B. So that's the part that you got to watch out for. It's not 28 over B. I'll see a lot of that. But remember that the angle bisector splits it into those parts, right? So I'm not using that whole side of the triangle. And then it's our cross product with here as well. So 15 times B, 15B, and 27 times 28 minus B. Don't forget that you have to distribute. And so now you just have a little bit of work. So 15B, got to distribute. So 27 times 28, which is 756. Go ahead and distribute here as well. 27 times negative B, which is negative 27B. And then get our B's to one side. So we add 27B, add 27B. And we got 30/42B equals 756. And divide by 42 to find out that B equals, so 756 divided by 42, B equals 18. And is that what it's asking for? Find the value of the variable. There we go. Done. Okay. So sometimes it's straightforward like the last problem. Sometimes you just got to think just a little bit to see how you can set up your proportion. There you go. Don't forget, you do not need to do number 18. And basically just setting up a lot of proportions today.